So graphing a parabola. I'm going to be graphing y equal x squared. I'm going to just be making a table of values here. But after I do the table, I'm going to just be trying to do it from understanding that all parabolas are very similar to just plain old y equal x squared. So let's say I've got my x squared that I'm going to be graphing. And let's say I do -3, -2, -1, 0, 1, 2, and 3. So I'm going to be squaring a -3, which is a 9. I'm going to be squaring a -2, which is a 4. I'm going to square a -1, which is a 1. Squaring 0 is 0. Squaring 1 is 1. Squaring 2 is 4. And squaring 3 is 9. So that is the points that I'm going to be dealing with for a regular y equal x squared graph. So I'm going to plot those points here and on my parabola for my plain old y equal x squared. So I'm going to be going 0 squared is 0. If I go over 1, as you can see in the table, 1 squared was 1. If I go over 2, like I have in the table, 2 squared is 4, so I'm going to go up 4. If I go out 3, 3 squared is 9, so I'm going to go up 9. And when I square a -1, I get 1, a -2, I get 4, and a -3, I get 9. So it's going to be symmetric, meaning the same on the other side. And then I'm going to connect this with a U shape with a curve. Zoom in. And that is my parabola. And my vertex for this particular parabola is going to be 0, 0. Now, what is going to happen is any parabola let's see if I can get it without this here. So just moving the table over. So any parabola that is not being stretched at all, but moved, is going to be the same parabola, just moved up, down, or left, right. So I just copied this parabola. I'm going to come over here to x squared minus 9. And what that means is if this is where my parabola would be, okay, where I have 0 squared is 0, and 1 squared is 1, and 2 squared is 4, and 3 squared is 9. The -9 moves this whole graph down 1. I'm sorry, down 9. And then at that vertex, that's where I'm going to be going out 1. 1 squared is 1, so I went up 1. Out 2. 2 squared is 4, so I go up 1, 2, 3, 4. Out 3. 1, 2, 3. 3 squared is 9, so I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And so on. And for this one, my vertex is at 0, 9. So let me jot that down. Now, I just physically took that graph and I moved it from over here. But what I want you to see is that all of these points are the same for all parabolas, but it's just being translated. Now, sometimes I will be stretching it, making it narrower or wider. But even if I stretch it and double it, where if I had plain old y equal 2x squared, I could just shift that graph. So every time I'm doing these graphs, I'm really thinking about these numbers here. Squaring a -3, I get 9. Squaring a -2, I get 4. Squaring a -1, I get 1. Squaring 0, I get 0. 1, 1, 2, 4, 3, 9. So let's say I do this one here without doing the copy of the graph. I will move it here to show you that it's the same. But what this is going to do is this x plus 5 squared, whatever makes this 0, okay, and -5 makes it 0. That's the direction I'm moving, left or right. So I'm moving to the left 5. And then I don't have anything add or subtracting here. So that means my y coordinate is 0. So then if I was going to be graphing this, I am going to be moving to -5, 0, 1, 2, 3, 4, 5. This is where my parabola is going to be. I don't have a stretch out here. So from here, I'm just basically graphing plain old x squared. If I went out 1 squared is 1. Same on the other side. From my vertex, if I go out 2 units, 2 squared is 4. 1, 2, 3, 4. If I go out 3, 1, 2, 3, 3 squared is 9. So I'm going to go up 9. So that's 5. This is going to be 9 up here. Now I'm going to take this other parabola that I had done up here. Let me get that again. Here, let me also get the points. Yeah, I'll do this one here. Okay. So if I was to take that graph, which was the same as my x squared graph, you see I got the same points. I got the same points. So when I'm moving these graphs, I am basically graphing 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, just located at a different spot. So this one here, number 4, what's going to make my x minus 3 0 is going to be a 3. So this is going to move over to the right 3. And then the minus 4 is going to move it down 4. And that's where my graph would have been. Okay. Now, what I would have done is the same thing I did here. I start here at my vertex, go out 1 squared is 1. So I went up 1. If I go out 2 from my vertex, 2 squared is 1, 2, 3, 4. If I go out 3, 1, 2, 3, 3 squared is 9. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, I'm getting the same exact parabola. For all of these, it's just being translated. And this vertex would have been 3. Whoops, make it a little thinner. This vertex would have been 3, -4. Now, if I have one like number 5 where I have a stretch, what's going to happen is all of my points are going to be twice as high. So, for example, if I was going to take this table, and let me just get rid of, I don't need those. If I was going to take this table, okay, I'm just going to put it right here. And let's say that I add on to this. So this was my x's, this was my x squared. And let's say that I make another column, but this time I have it be 2x squared. Let me just move this down. Move it down to here. Okay. So let's say that I was graphing 2x squared. So what that means is I would take my x, square it, okay, square it, then I double it. So I square it, I get 9. I double it, I get 18. I square -2, 4. I double it, I get 8. I square -1, I get 1. I double it, I get 2. I square 0, I get 0. I double it, I get 0. I square 1, I get 1. I double it, I get 2. I square 2, I get 4. I double it, I get 8. And I square 3, I get 9. I double that, I get 18. So I don't care if it's number 5 or 6, okay, or 12. Each of these that has a stretch of 2, I'm basically thinking about these heights here. If I go 1 away, 1 squared was 1, and then I double it, I'm going to go up 2. 2 away, 2 squared is 4, I double it, I get 8. I'm going to go 8 up. 3 squared is 9, I double it, I get 18. So on this problem here, number 5, my vertex is going to be -1 because of the x plus 1. -1 makes that 0, comma, -8. So I am going to go to -1, -8. So -1, -8. So 5, 6, 7, 8. And then I'm thinking about going out 1 and 2 and 3. And when I go out 1 from my vertex, 1 squared is 1, but my stretch is 2. So that means I'm going to double it like all of these were doubled. So if I go out 1, 1 squared is 1, double that, I'm going to go up 2. If I go out 2, 2 squared is 4, double 4, I get 8. I go out 1, 2, 3, 3 squared is 9, double 9, I get 18. And that's going to actually be here at the tippy top if I go 18 above. And then I'm going to connect. And that would be my parabola. Now, if I'm doing one like number 6, again, I'm really taking the same parabola, but it's going to be flipped. Okay. So first off, let me find my vertex. So my vertex, because of this, is going to be -3, and because of this, comma 8. So I am going to go to -3, comma 8, which is up here. And I'm still going to be going out 1, squaring 1, going out 2, squaring 2, going out 3, squaring 3, but I'm going to times it by -2 because of this stretch. So if I go out 1, 1 squared is 1, like I had here. So out 1, 1 squared is 1, I times that by -2, I get -2. So I'm going to go down 2. If I go out 2, 2 squared is 4, and then I double 4, I get 8. It's going to put me right here. If I go out 1, 2, 3, 3 squared is 9, I times 9 by -2, and I get a -18. And that's our parabola. It's an open down parabola. So if I was to take this graph, for example, and look at this one here, my vertex here is going to be at -3, 5. So I'm going to go to -3, 5. Let me just move this. -1, 2, 3, 5. And that would be my parabola. Again, what I did was I went to my vertex, I went out 1, 1 squared is 1, times it by my -2. So that's a -2. I go out 2, 2 squared is 4, times it by that -2, -8. I go out 1, 2, 3, 3 squared is 9, times it by -2, I get -18, which would be down here. Now, if I'm doing one with a different number, it's going to be the same idea. So for example, this 1/2 here, first off, this vertex is going to be at -2, 0. And I am going to plot this. And when I do, okay, I'm going to go to -2, 0. Now my stretch is a 1/2. So as I go out 1 squared is 1, times it by a half. So I'm at a half. I go out 2 squared is 4, times that by a half. I get 2. So everything's half as high. So if I go out 1, 2, 3, 3 squared is 9, I'm going to go half of 9, which is 4.5. And if I went out 1, 2, 3, 4, 4 squared is 9. 4 squared is 16. I take half of 16, which is 8. And then that would be my parabola. Now, one like number 11, let me just copy this. And let me paste it on this page. And you'll see that every point is half as high. Every point is half as high, half as high, half as high. Now, when I'm doing one like number 11, my vertex is going to be -8. So I'm going to 0, -8. So I come down here to 0, -8. And that would be my graph. And again, what happens is I go out 1 squared is 1. I take half of that. I'm at a half. I go out 2 squared is 4. Half of 4, I go up 2. I go out 3 squared is 9. Half of 9, 4.5, and so on. And that's your graph. So hopefully this helps a little bit.